Dear students, I am Pratima. I welcome you all to this video. So today we'll learn another case study question from application of derivative. We have already done 2 questions. If you have not watched the video, you can watch it. So this will be asked in the new pattern class 12 examination. So we should learn some more case study questions. So first question is, Raj is playing. So when a question is of a case study, you have to read very carefully because it carries your 5 marks, and each there are 5 parts. Each will be giving 1 mark, and there is a relation between the questions. So let us read the question. Raj is playing a spring by throwing it in the air, which is moving along the function fx is equal to 3x to the 4 minus 4x cube minus 12x square plus 5. So this is the spring, figure is given. Now from this given case study, we have to answer the following questions. First is, find the critical points of x which it touches x-axis. Next is, these options are 0, 1, 2, 0, minus 1, 2, 0, 1, minus 2, 1, 2, minus 2. Second question is, find the interval in which spring is strictly increasing. The options are minus 1 to 0, union 2 to infinity. 2 to infinity, union 1, comma 0. C is 1 to infinity, D is 0 to infinity. So this is about increasing function. Third part is, find the interval in which the spring is strictly decreasing. So once you get the increasing, you can get the interval for decreasing, no problem. Find the values, the options are minus infinity to minus 1, intersection 0, 2, then minus infinity to 2, minus into minus 1, union 0, 2, minus 1 to 2. And fourth part is, find the value of x at which the spring has local maxima 2, minus 1, 1, 0. What is the value of height caused by the spring? Maximum height 10, 72, 5, 0. So we'll go one by one. First is, find the critical points of x which tosses the x-axis. The options are 0, 1, 2, 0, minus 1, 2, 0, 1, minus 2, 1, 2, minus 2. Now what is critical point? Critical points are the values of x for which the derivative is 0, f dash x is 0. So find the derivative very correctly. Fx is equal to 3x to the power 4 minus 4x cube minus 12x square plus 5. So f dash x will be certainly 12x cube minus 12x square minus 24x. Make it 0. Then factorize. You can take 12x common outside. It will be x square minus x minus 2. Make it 0. Again factorize. By the splitting the middle term, you will get x minus 2 and x plus 1. So this gives you the values. One is x is equal to 0. One is x minus 2 is 0, so x is equal to 2. And third is x plus 1 is 0, so x is equal to minus 1. So critical values are 0, minus 1 and 2. What is the answer? B. B is the answer. Next, second part, find the interval. Find the interval in which the spring is strictly increasing. The intervals are minus 1 to 0, union 2 to infinity, 2 to infinity, union 1, comma 0, 1, infinity, 0 to infinity. And what is increasing function? For increasing function, for interval, we know that derivative of the function should be greater than 0 or positive. So we have already got f dash x. How much it is? It is 12x, x plus 1 and x minus 2. And the values were x is equal, critical points were 0, minus 1 and 2. So I'll make a number line minus infinity to infinity. Next is first is minus 1, 0 to 2. Now for each interval, I'll test whether it is positive or negative. So first I'm going for minus infinity to minus 1. This is the interval. Now I will put in f dash x. So when you will put x is equal to, in between any value, we can assume that let it be minus 2 is the value. So this will be, in place of x, I'll put minus 2. So this will be negative. Then in x here, I'll put negative. So again, it will be negative. In x minus 2, I'll put minus 2. It will be negative. So I'm getting negative. So f dash x is negative in minus infinity to minus 1. What does it mean? F dash x decreases. F dash x decreases in minus infinity to minus 1. And you know, very interesting relation. If 1 it is decreasing, then next will be increasing. Next interval again decreasing. And next interval it will be increasing. So no need of finding other. First one it should get very correctly. So where it is increasing, it is increasing. Fx increases. It is not f dash x, fx increases. Fx increases in your minus 1 to 0 union 2 to infinity. So where is the answer? A is the answer. A is answer. So please make a correction. F dash x is negative, then fx decreases. Not f dash x decreases, it is fx decreases. And when f dash x is positive, fx increases. So here it increases in this interval and increases into to infinity. Next, coming to third part. Third part is now we have already done while doing part 2, because we got the interval. Again, I'm repeating, negative 1, then negative 1, 0 to infinity. So first we got decreasing, increasing, decreasing, and increasing. So we can write this part. The answer is minus infinity to minus 1 union 0 to 2. Where is the answer? C is the answer. C is answer of this question. Fourth part, find the value of x at which spring has local maxima. So what are the concept? Concept is for local maxima, first f dash x is 0, get the critical point. Next I'll go for second derivative. If f second derivative is negative, then x is local maxima. So for this, I'll find second derivative. What is the first derivative? Let me write again. Fx is equal to, in examination, no need of writing because we have already found. But here I am doing again because in front of me on the screen it is not there. That's why. So this will be 12x to the power 3 minus 12x square minus 24x. This was first derivative. And we got the critical points 0, minus 1, 2. These are the value of x. Making it 0, we got this value. Now second derivative. Second derivative will be your 36x square. minus 24x minus 24. So derivative of this 36x square minus 24x minus 24. Next I'll go for every value. First I'll put 0. What is the value? Negative 24. So 0 is local maxima. Then next I'll go for f minus 1. F minus 1, if we'll put my f minus 1 plus x minus 1, then this will be 36 plus 24 minus 24. Then I'm getting positive. It is 36, which is positive. So minus 1 is minima, not maxima. When I'm getting minima. Next, coming to third one. Third one is F2. F2, it is clearly visible that it will be positive. If I'll put 2, it will be 144 minus 2, 48 minus 24. So this will be positive. So when it is positive, so 2 is minima. So there are two minima, one maxima. Question is about maxima. So what will the answer? Answer will be 0 is local maxima. So please remember, for which critical point you get second derivative is negative, second derivative is negative. That is your x is local maxima. So there was three value 0, minus 1, 2. For 0 we got negative. Second derivative negative. So it is local maxima. So 0 is local maxima. D is answer. Now last part. What is the maximum height caused by the spring? 10, 72, 5, 0. So for maximum height, you will take the local maxima as x. So what was the local maxima? Local maxima was 0. So put 0 in the function. So it will be 3 into 0 to the power 4 minus 4, 0 to the power 3 minus 12 into 0 square plus 5. What is the answer? Answer is 5. So where is the answer? C is answer. So I hope you have learned. Keep on watching. We'll do some more questions in between. Subscribe the channel, press the bell icon so that you can learn more and more. Thank you for watching.